everyone, welcome to the Math STEM Science Summer Camp, hosted by Millicent Robotics. I'm your resident math scientist, Leo, and today we're going to be talking about gravity. Now, when we talk about gravity, we have to make an important distinction between mass and weight. Now, you might have heard them before. You can say that, well, say this apple, it weighs, or has a mass of 200 grams. You can also say it weighs 200 grams, but that doesn't mean the same thing everywhere. And when I say everywhere, I don't mean just like if I'm here then it weighs 200 grams, however if I'm in Canada it weighs 170. No, I mean on different planets. Because weight is dependent on gravity while mass isn't. And that's really useful to make sure that we can say that this apple has the same mass here than it does on the moon. Now, mass is how much matter there is in an object. And matter is, well, the existence of, well, stuff. So like this paper is made up of matter made of carbon. And now the mass of the paper is how much molecules there are, and the weight of the paper is how much those molecules are being pulled by the planet we're on. And because of this distinction, we can say that our mass here on Earth is the same as if we were on the moon. However, our weights would be different. I would have a lower weight on the moon because of the less gravity. That'd also mean I'd be able to jump a lot higher than this. Now let's talk about gravity. You know, it's said that the famous scientist and mathematician named Sir Isaac Newton in the 17th century was watching an apple tree when the apple fell down off the tree. And he knew there must be some force acting on the apple that'll bring it down to the earth. He went on to explain that force as gravity. Gravity, as we know it, is the force of attraction between everything with mass that scales back as you get farther away. Now, because the Earth is so massive, and everything else comparably massive is so far away, like the moon or the sun, it's really the only thing we experience in day-to-day lives. So everything, just gravity, falls to the Earth. However, that doesn't mean that there aren't other gravitational forces at play. Dear viewer, despite how far away we are, because we both have mass, we are attracted to each other, and you are attracted to everything around you. Now, while the Earth may bring this apple down to the ground, because forces aren't one-way direction. Gravity isn't one way. The same amount of force that brings the apple to the ground also brings the Earth to the apple. But if you watched our Newton's Laws of Motion video, you know that the Earth wouldn't move that much because it has a much, much larger mass. Now, gravity, as we know, on Earth may only be between us and the Earth, things falling down. But as we get into larger scales, like in space, we can actually see gravity at play in other places. For example, our moon. Now, the Earth and the moon are massive enough and close enough that they interact with each other. And this is such that as the moon is flying through space, it's being just enough to bring it into orbit. And that's how orbits are. Orbits are a combination of how fast something is moving, as well as the gravitational pull between the orbiter, and the orbitee. Now that we know that gravity pulls everything to the ground, now that we don't see everything on the ground. So how does it get into the air? We see birds flying, we see insects flying, we see planes flying across the sky. How are those flying? How are they supposed to fight gravity? Now this is because there can be more forces acting on an object. While gravity pulls something down, some animals and our planes that we've created have a way to create a force up. This force is known as lift, and it's created by planes as the plane wings fly through the air. The way that they shape the wings make it such that the plane will be lifted up by the air they're passing through. And this leads to four forces that we observe on most planes. Those forces are, well, gravity, lift, as we just learned, two opposing, one down, one up. We have thrust, which is the force in the direction that's moving, and we have drag, which is the force of friction, normally from the air, that opposes the thrust. And all these forces together if you weigh them in such a way, you can design airplanes and other air flying machines. And you know, I may not be able to help show you how I build an airplane. I am going to be able to show you how to build a paper airplane. And you know, this is a really good one. This is one of the best gliders in the world, so it utilizes lift effectively. Let's go take a look at how to make that. Alright, here we have our standard 8.5 by 11 sheet of paper. We're going to make one of the best glider airplanes there is. This, in fact, won a world record. So to start, we're going to take one of our corners and line up this edge to this edge. We're going to make a right triangle. We're going to take, so we see, lining up the edges, make sure our corner is sharp, and create the seam. There we go. Nice. We're going to do this also the same way, but on the other corner. So using this corner, we can use this seam as a guide. Put it to this corner. Make sure our corner is nice and sharp, and make that seam. Nice. So right now we have an X in our paper, right? We are going to now fold it and make it look a little bit more like when the paper airplane should. So we're going to take this edge here and fold it along the seam that we created. So we're going to take our corner and fold it in, like so. This is going to create a little horizontal line here. And we're going to do the same on the other side. So this corner, take it in. Nice. So now we have, well, it's starting to look more like a paper airplane. Now the next step is we're going to fold this down. And as we fold it down, we might see a little bit of an X here. We're going to line up this X, or these two lines of the X specifically, with the piece of paper. So we're going to line it up like so, because we want this X to form a nice line here and here. There we go. Fold it down. This is how you know that you folded it down enough. Now the next step is to fold this corner, actually the piece of paper in half. You can do this really at any step before this, but I'm going to do it now. And we can see that since we folded it nicely, it's laying over very nicely. It won't lay over perfectly if you do a little bit of messy folding, but that's okay. Nice folding comes with experience. So now we're going to take this top line and fold it in. So we take our corner and we move it in. And we're going to do the same with the other corner. And finally, we're going to fold this bottom flap up. And this is a really good paper airplane. And now that we built this plane, let's see how this glider flies. Now the wind may have caught it near the end, but we saw it did start to steer towards the other way. That's because the two wings on that plane aren't exactly equal. So the lift pushing up on both sides wasn't equal, and the stronger side is going to make it so the plane tilts and flies in that direction. Alright, in review, today we learned about the difference between mass and weight. We learned about gravity, how it pulls everything with mass together towards each other. Things with higher mass get pulled stronger, and things that are farther apart get pulled less. And we finally learned about the 4 different forces acting on the plane: lift, gravity, thrust, and drag. Thanks for watching this video on gravity. I hope now you have confidence that if you jump, you're not going to float away. Make sure to catch our other camp videos for more fun experiments and science.